All right, on to example 7. It says, excuse me, an alternating current I in amps in a certain circuit can be found after t seconds using I as 3 times sine of 165 times t, where 165 is a degree measure. It wants us to rewrite the formula in terms of the sum of two angle measures and then use the sine sum identity to find the exact current after 1 second. Okay, so we want to use our sine sum identity and replace 165 with two angles being added together. Okay, so let's think of two angles. And we know we're doing sum because it says right here, use sine sum identity. So two angles that we know from the unit circle that will add to 165. So the two that come to my mind first are 120 and 45. Okay, so I'm going to use that. I'm going to replace 165 with that. So I'm going to say, okay, so I is 3, and then I'm going to use brackets to show I will do the sine of 120 plus 45 first. It's in brackets. Okay, and then you've got t on the outside. Okay, so it says rewrite that formula in terms of the sum of two angle measures. So that piece is done. Because what I did here is I replaced the 165. Okay, that's what I substituted in. And this is my sine of u plus v. So 120 is my u, 45 is the v. Now it wants us to use that identity to find the exact value after 1 second. Okay, well, the time is going to be plugged in here for t. So I'm going to plug in 1 for t, which is going to be nice because we know multiplying by 1 is not going to do anything, so I really don't have much to do for that portion of it. I've still got that 3 in front. Okay, now I'm going to expand using my sine sum identity. So remember that would be sine of u, which is 120, cosine of v, which is 45. We keep the sign, so plus, and then cosine of u, sine of v. All in brackets because I got to take care of all that first. And then I'm plugging in a 1 here for t. All right, so think about your unit circle. You should know these values. At 120, sine is root 3 over 2. At 45, cosine is root 2 over 2. At 120, cosine is negative 1/2. And at 45, sine is root 2 over 2. I gotta take care of all that first. Now the 3 times the 1 is just a 3, so I'm gonna go ahead and drop that 1. All right, so within this, I've got root 6 over 4 and negative root 2 over 4. Okay, and then I can go ahead and combine that, or I can go ahead and distribute the 3. It doesn't really matter if I distribute now or combine first. Either way, the 3 is going to get multiplied by both of the terms in the numerator. So I'll go ahead and distribute now. And we know that plus a minus or plus a negative just becomes minus, right? Okay, and now I can combine those to a single numerator over this common denominator. And I can't simplify any more than that, and the unit of measure was in amps. So that's the number of amps used after 1 second. All right, last but not least, to solve for x on the interval 0 to 2 pi. So that just means give your answer within one revolution, one circle, one time around. the unit circle. Now it says to, we've got combination of sum and difference identities here. Okay, so I'm going to try and color code this for us. So we've got sign sum ID right here, and we've got the sign difference ID here. So I'm going to have to expand both of those. Okay, but think about your order of operations. You got to do this, you got to do this, and then we'll add it all together. Okay, and simplify sum, and it's all set equal to -1. We'll finish solving for x once we get to that point. Okay, so in the first sign sum ID here, I'm going to expand, x is my u, pi fourths is my v. So that is sine of x cosine of pi fourths plus cosine of x sine of pi fourths. All of that came from that piece, and that's being added. Okay, and then we'll expand this piece here. So that would be sine of x cosine of pi fourths minus cosine of x sine of pi fourths, and it all still equals -1. All right, now we really don't need the parentheses in this one because this is a plus sign here. If I tried to distribute a plus sign to everything, it doesn't change. Okay, so everything stays as is. We can really just drop the parentheses. If you want to make a note of that, you can make yourself a little side note here. Because it's a plus, we can drop the parentheses. If it were a minus, we would have to distribute that minus to both of these terms over here. Okay, but because it's a plus, we don't. So you can drop the parentheses, you can write a whole new line. Without the parentheses, I'm literally just going to erase them because I can do that on this computer easily. It's going to save us some time. All right, so without the parentheses now, I see two like terms here. Okay, sine of x cosine of pi fourths, it's there twice. So 2 sine of x cosine of pi fourths. Okay, and then my other like terms here, cosine of x sine of pi fourths, I've got one positive and one negative. So those completely cancel each other out to 0. It's gone. And this is all still equal to -1. Okay, now I'm trying to solve for x. So I want to isolate the trig function. This is kind of combining it with what we did in 5.3, solving trig functions. So I'm going to get rid of this coefficient of 2 and go ahead and actually, I'm going to do my order a little different. I'm going to replace this. I know cosine at pi fourths is root 2 over 2. Okay, and that's being multiplied by sine of x, and that's being multiplied by 2. All still equal to -1. Now I've got times 2 and times something over 2. Those reduce. Multiplying by 2, dividing by 2, reduce to a 1. Okay, so now I've got root 2 times sine of x. I'm going to write that in front like a coefficient. Now I'm going to divide that over. So I've got, I'm going to come over here, sine of x equals -1 over root 2. We rationalize, we do not leave radicals in the denominator. So when I multiply by root 2 over 2, that gives me sine of x is negative root 2 over 2. Now I can answer the question. I've isolated the trig function. That's a measure, not a measure. That's a trig value that you should know from the unit circle at a certain measure. That's what we're looking for. At what measure? What is x? Is that the sine value? Okay, well, let's think about this. If you need to, sketch it. If you don't, Don't worry about it. Remember, this is asking, at what angle is sine negative root 2 over 2? Well, first of all, sine is negative in quadrants 3 and 4. So we know our answers are coming from 3 and 4. Okay, and you can have more than one answer. And we're going to, because there's two quadrants between 0 and 2 pi, there's going to be two values where this is true. Okay, and that's at a 45-degree reference angle. So 45-degree reference angle in both of these quadrants. So here, and since it gave it to us in these given angles all in radians, we want our answers in radians. If you want to start with degrees and then we'll convert to radians, that's fine. Or if you know it in radians right away, that's good too. But a 45-degree reference angle here in degrees is 315. But again, we want our answers in radians. Okay, so that is 5 pi fourths, and that is 7 pi fourths. So those are my two solutions for that original problem. We solved for x. Both of those values would make this true.